Hey guys, welcome to the video for elimination. We are in Unit 5. Our essential question is, how is the elimination method used to solve a system of equations? Just like the substitution notes, the copy machine was a little bit messy on this one, so if you've noticed, like, my lines here are not really connected because it copied funny. So as we go throughout the notes, I will be correcting things, so just make sure you're correcting them on your notes as well. All right, so after that little intro there, we've talked about solving systems of equations, and that's what Unit 5 has been mostly about. We're solving systems. And systems are when we have more than one equation. So when we have two equations, we call that a system. And I apologize for saying a lot. I don't mean to. I'm just like thinking. But we have a system of equations and we want to solve it, and there's lots of ways we can do, or lots of ways to solve one thing, right? Like there's multiple ways to solve an equation. Not everyone solves an equation the same way. So the first method that we learned to solve systems is by graphing. We would graph the equations or inequalities. We would put them on the graph and see where they intersect, and wherever they intersect is where the solution is. And if they don't intersect and they're parallel, there's no solution. And if we graph both lines and they're the exact same line, we have infinitely many solutions. With substitution, we basically were able to get the same exact answers. We were just solving it more algebraically. So with substitutions, you're trying to get a variable by itself. And today we're going to learn about elimination. And this is the third method, and it's the final method we learn how to solve a system of equations. Okay, so before we begin, I want to ask you for a little bit and think. What do you think of when you think of elimination or eliminate, right? You probably think of get rid of or cancel or take away, right? You want to get rid of something, you want to eliminate something. So that's basically the point of this lesson, is you're going to be trying to eliminate a variable or getting rid of something. Just like with substitution, you're substituting something in. So an example of substitution, like yesterday or the previous day, you were given something like x equals 2y minus 4, and then 3x plus 4y equals 7, something like this. And then you were like, oh, substitution. I know what to do. I take this value and I plug this in for x, right? And you were like, well, this one was super easy to do substitution because they already got an x variable by itself, and so I can substitute really quickly. But what if I gave you something that looks like this? Right? If I gave you something like this, which one of these would be easier to do substitution with? The first problem or the second problem? The first one is way easier to do with substitution. The second problem is a lot harder to do with substitution because you don't really have a variable by itself, so you're going to have to do a lot of algebra in order to get that variable by itself, and that's because they're in standard form. So with elimination, we need all of our equations to be in standard form. Once they're in standard form, we can go ahead and do elimination. And just a reminder of what standard form is, that is ax plus by equals c. Okay, so with elimination, you want it in standard form. Okay, so beginning with number 1, you always want to make sure your problems are stacked, or your equations are stacked up upon each other. So instead of writing them like on the left side and on the right side, you're going to have one on the top and one on the bottom. And I want to bring you back to like kindergarten, first grade, when you were learning problems where you were like, the teacher would ask you 23 plus 15. And you remember doing problems like this, and you would have to add, and you would add vertically, right? You would do 3 plus 5, you get 8. And then you do 2 plus 1, and you get 3. So you go up and down, you go vertically. It's going to be the same type of concept with number 1. So the first thing I'm going to ask you is I'm going to ask you to draw a giant plus thing. I want you to draw a giant little line where you would add these together. You are always going to add. You are never going to subtract. So do not put a subtraction sign. You will always put a plus sign because you do not want to create another issue as you're doing this. So if you do plus sign, everything should be fine. Okay, now you do the same thing. You're gonna treat it vertically. This is why we need it stacked up upon each other. You want to make sure that everything is stacked upon each other. And you want to make sure it is in standard form. And both of these equations are already in standard form. Now, before you can even add or do anything, and first of all, you should be taking notes. And if you're not, shame on you. You need to print the notes and take them, or doing them on your iPad, however you're doing it. But you should be taking notes. You're going to ask yourself, well, what's the easiest thing for me to eliminate? And when I ask you that, what I mean is, if I had 3x, and I asked you, how do I get rid of a positive 3x? Well, you would say subtract 3x so that you get 0. So you're looking for opposite signs. Anytime you have opposite signs, that's going to be a key indicator that that's going to be the thing that's easiest to eliminate. So as I'm looking at my x's and my x's are both positive, but my y's are opposite signs. One's positive and one's negative. So that leads me to think that's the easiest thing to eliminate. Just with substitution, you're looking for the variable that's by itself. Here you're looking for which one of these has opposite signs. So you're going to go ahead and go vertically, and you're like, well, I know I'm going to eliminate, and you want to look at it. Y minus y would give me 0, right? So let's go ahead and start. We have x plus x, so you're going vertically. X plus x, which gives me 2x, okay? And then I have y minus y, which gives me 0y. So these cancel, and they no longer exist. I have eliminated them. That's why it's called elimination. Haha. Okay. Equals 12 plus negative 8, which is going to give me positive 4. And then from here, I'm going to solve for x. Divide both sides by 2. And then I have x equals 2. Now with substitution or with graphing, anytime you have a solution, you want to write your answer as an ordered pair. So right now we only have half of our ordered pair. We have the x value. Now we need to get the y value. Elimination is kind of a hybrid between substitution, right? Because you still have to use substitution to get the final answer. So when we were learning substitution, we would take whatever we got here and we would substitute it into one of our equations. So I'm just going to go ahead and pick the first equation. X plus y equals 12. And I'm going to substitute in my x equals 2 into my x value. So I'm doing the same thing I would do with substitution. And anytime I plug in, I always use parentheses. Okay? So then I'm going to 2 plus y equals 12. I'm going to subtract 2 on both sides. Y equals 10. Okay? So I have my y value now. And I circle because that's not my final answer. My final answer would be the solution 2, 10. Because that's the ordered pair. That's the point. You always want to make sure you write it as a point because that's where the two lines are going to cross each other. So let's test this in Desmos. We have x plus y equals 12. And we have x minus y equals 8. So we have two lines that cross here. And if I click on their intersection, it'll pop up a gray dot. And if I click on that intersection one more time, it'll give me what the point is, 10, 2. Oh, did I type this in wrong? Oh, I did. I put negative. Okay, I forgot the negative 8. Okay, you're like, I'm like freaking out because I'm like, did I do something wrong? Okay, sorry. I typed the equations wrong in Desmos. Anyways, if you click on the intersection and you click on it one more time, it will show you the point, 2, 10, which is what we have, and we were correct. I just typed it in wrong. Okay, so elimination is actually pretty easy, and you use substitution to still get your answer. I'm going to be honest, a lot of us tend to forget elimination by the time we have a STAR test. So when you have the STAR test, you're going to forget. And that's okay because you still have the fallback of substitution, and substitution is usually the thing that you remember more. Okay, so the first thing you always want to do, well, not really always want to do, you want to check to see if you can eliminate anything. So you want to check, can I eliminate something very easily here? And you're like, yes, I can eliminate the positive 5y and the negative 5y. So at that point, that's when you draw your little plus sign, your little addition and your line, okay? And you always do addition. You do not do that until you are certain that you can eliminate something. Okay, so positive 7x minus 4x, or plus negative 4x, is going to give me positive 3x. I'm going to use a different color, red. Okay, 3x. Positive 5y minus 5y cancels and gives me 0. We're eliminating something. Equals 26 plus negative 17, which gives me positive 9. And then you're going to divide both sides by 3. You get x equals 3. Once we're going to substitute, so you pick one of your equations. It does not matter which one. I will pick the first because it's the first one I see. I'm going to take my value here, and I'm going to plug it in for x because it says x equals 3. So you make sure you substitute it in for the correct value here. And anytime I plug in, I always use parentheses so I do not make a mistake on accident. Okay, 7 times 3 is 21. Then I'll subtract 21 on both sides. Divide both sides by 5. 5 divided by 5 is 1. So my solution is 3, 1. Now, how can you check this? You take your point, you take the point and you plug it back into one of your equations. So you can plug it into the first equation or the second equation, and if both sides equal each other, then you got it correct. Just like with substitution, we can check with these. All right, moving on. Number 3. Now, this is one of those where the printing was off, so make sure you're fixing it on your paper. This should be a plus sign, and this should be an equal sign. So we have 5x plus 6y equals 4, and 7x plus 6y equals 8. Okay. Now, before you draw your little addition table, you want to look and see, is there something here that I can eliminate really easily? Not really, right? Because you don't have opposite signs anymore. But you know that you also have to have opposite signs and the same number, right? If we go back to the last one, we were able to eliminate 5y and negative 5y because they were opposite signs and the same number. Here, we don't have opposite signs, but we do have the same number, 6y and 6y. They have the same coefficient. So here's where we have to do some manipulation, right? What we've learned with the previous unit is that anytime you multiply the entire equation by a number, it's still the same equation, it just looks a little bit different, right? So for example, if I have 4x equals 2, and I multiply everything, well, hold on, let me do a more sophisticated example here. Okay, I have 4x plus 2y equals 8, and I multiply everything by 2. Let's just say, for example, I multiply everything by 2. Then I have 8x, and you don't have to do this, I'm just showing you. It's something good for you to see. And then 2 times y, which is 18. So I now have two equations. I have this equation, and I have this equation. The only difference between these two, I just multiplied wrong. I just realized. 16. The only difference between these two equations is that I've multiplied one of them by 2. But if I were to graph both of these in Desmos, 4x plus 2y equals 8, and 8x plus 4y equals 16, if I click back and forth, they're exactly the same line. So it's like plastic surgery. We're doing some plastic surgery to these equations. They're the same exact equation. They're the same equation down deep inside, but it just looks a little bit different. Kind of like someone who has plastic surgery, right? If they get plastic surgery on their nose, they're still the same person. They just look a little bit different. So that's what we're really doing here. So I can go ahead and make a note. Oops. The same equation. It just looks different. Okay? So with number 3, I'm going to have to do some plastic surgery here because I can't really eliminate with what I've got so far. So you're going to pick one and you're going to do plastic surgery on it. Okay, I'm going to pick the first one. I'm going to pick this first equation. And I want to multiply this entire thing by something. And I know normally I multiply like each side of the equation by something, and you can do that. So we can go ahead and do it that way, actually. So I know you guys aren't used to really seeing it this way, but there we go. Okay. And I have to fix this because now it's bothering me. Okay, so we're going to do some plastic surgery on this. Well, what do we need to multiply this equation by in order for the other equation to eliminate? Well, I want to eliminate the y's because the y is the easiest thing for me to eliminate because the numbers are already the same. This is positive 6y. So I need the other equation to have a negative 6y. Well, what's going to make everything change signs? Multiplying by a negative 1. So I'm going to multiply this side by negative 1, and I'm going to multiply this side by negative 1. Okay? So I'm going to do negative 1 times 5x, which is negative 5x. Negative 1 times 6y, which gives me negative 6y. And negative 1 times 4, which gives me negative 4, right? And then I'm going to go ahead and copy down the other equation back down here. So this equation in red, or the one that I just started, I'm going to go ahead and copy it down here. Okay. So I'm going to write that one again because I didn't do any surgery on it. Now when I look at my equations, yes, the green one looks different from the one I had previously, but again, it's the same equation. I just multiplied something. I multiplied a number by everything, so it's still the same line. So now that I can actually eliminate something, I'm going to go ahead and draw my plus in my line. Negative 6y plus 6y cancels this time, so we're good. Negative 5x plus 7x is positive 2x equals positive 4. And divide both sides by positive 2, x equals 2. So my x value here is 2. Once you're finished, you need to pick one of your original equations to substitute in. So I'm going to pick 5x plus 6y equals 4. So the very first equation we did plastic surgery on, I'm going to pick the original equation. And I'm going to take x plus 2, or x equals 2, and plug it in for my x value. So I have 5 times 2 in parentheses, because anytime I plug in, I use parentheses, plus 6y equals 4. So this is going to be 10 plus 6y equals 4. Subtract 10 on both sides to get y by itself. And divide both sides by 6. So then I have y equals negative 1. So my solution is 2, negative 1. So if I were to graph these two lines, they would intersect at the point 2, negative 1. Okay? So the only thing about the first two problems that was super easy was that it was already set up really nicely for elimination. But with number 3, we had to do a little bit of work. So sometimes elimination can be really easy. Sometimes it can be a lot of work on us. All right, number 4. Okay, you want to look. Okay, so the first thing you always check for is you see if you can eliminate something. And you're like, well, doesn't look like I can really eliminate anything because I have nothing that's the same number, right? But what do you notice? You do have opposite signs. You have a positive 8 and a negative 4. Those are opposite signs. You always want to look for the things that have opposite signs, and then things will be a lot nicer for you. So because negative 5y and negative 3y, they're not the same number and they're the same sign, that doesn't really help me. I want to find the thing that I can eliminate the easiest. So you always look for either the same number or you look for opposite signs. And if they have both, then that's even more awesome. So because 8x and negative 4x have the same, have different signs, those are the ones I'm going to try to eliminate x here instead of y. X is the easiest thing for me to eliminate. So I have to first get them to be the same number. So what's a number that 4 and 8 have in common? Well, I can get 4 to become 8 if I multiply everything by 2, right? So we're going to do some plastic surgery on this second equation. We're going to multiply everything by 2. And I'm going to go ahead and do the multiply by 2. And I'm going to do the parentheses around the entire thing. I know that's a little bit different than what we normally do, but that's okay. So we're doing 2 times negative 4. That's going to give me negative 8x. 2 times negative 3y, which is negative 6y. And 2 times negative 12, which is negative 24. Okay? And then I'm going to star the first equation because I'm going to bring it down to the bottom so I can have them stacked on top of each other. So I'm just copying down that first equation. Okay? Now, why did we multiply by 2? We're trying to get rid of one of our variables. We're trying to eliminate one of them. And the easiest one to eliminate was the x variable. So I wanted to do some plastic surgery, some manipulation to get rid of that x variable. So now I can see clearly that I can eliminate my x's. So negative 8x plus 8x is 0 and eliminates. Negative 6y plus negative 5y is negative 11y. Equals negative 24 plus negative 20, which is negative 44. And then I'm going to divide both sides by negative 11. Positive 4. Okay, so the hardest part about these is basically doing that manipulation. But once you've got it past that, then you're pretty good. Okay. And then I'm going to pick one of my equations. I'll go ahead and pick the same one from earlier at the top here. Remember, you need to pick one of the originals. So it doesn't matter which original equation, just you need to pick one of them. I'm going to substitute the y value in. So I have 8x minus 5 times the 4 in parentheses equals negative 20. So you have 8x minus 20 equals negative 20. And I add 20 to both sides to get x by itself. 8x equals negative 20 plus 20 is 0. And you do not want to stop. You want to keep going because x is still not by itself. You divide by 8. X equals 0 divided by 8, which is 0, okay? Make sure that if you do not know that, you are using a calculator to help you. So you have x equals 0. So my solution is 0, 4. That's where they intersect. All right, number 5. We have 10x minus 5y. Oops, I'm sorry, I did not mean to move the iPad so much. This is minus 5y equals 5. And then 2x minus y equals 1. Okay. Okay, now we're in that, we're like, well, you just said to look for opposite signs and we don't have any. And then you said to look for the same number and we still don't have any. I'm like, you're right. So it's not always going to be very easy for us to do elimination. We've got to manipulate a little bit more. So you want to look. Is it easier for me to get my x values to be the same number, or is it easier for me to get my y values to be the same number? And that might be hard for you to see, but the y value is the easiest thing for me to get to the same number. So I know that these have the same sign. They're both positive and these are both negative. However, in order to just multiply equation by only one thing, I can multiply this entire thing by -5. And here's why I chose -5, right? The other y has a -5. So in order for this y to eliminate and cancel, you need it to be a +5. Well, right now it's a -1. So if I multiply everything by -1, it'll become a +5. So you're trying to figure out which one's easiest to eliminate. So -5 times 2x is going to be -10x. -5 times -y is going to be +5y. And then -5 times 1 is going to be -5. Okay? And then I'm going to bring that first equation down so I can stack them on top of each other and do my math a little bit easier. Okay? And then I'm going to make sure, hey, can I eliminate something? And you're like, yes, I can eliminate my x's now. And my y's, actually. So if I look, I have -10x plus 10x. That equals 0, right? Cancels, goes away. 5y minus 5y is also 0, so I have +0. Equals -5 plus 5, which equals 0. So what do I really have here? I have 0 equals 0. Is this true? Yes. Is it always true? Does 0 always equal 0? Yes. Because these are true and it makes sense, this is going to give us infinitely many solutions. Just like with substitution, when I get two numbers that are the same and they equal each other, that means I have infinitely many solutions. And you can write IMS because it does take a lot of writing, right? All right, we have 3 examples left. Number 6. All right, number 6 is our first tough one because we got to manipulate some things here. Okay, I got -5x plus 3y equals -31, and then I have -2x minus 5y equals 0. Okay, so first you want to look. Do you have the same number anywhere stacked on top of each other? No. Do you have opposite signs? Yes. I have opposite signs here, right? I have a positive and a negative. Okay, now I can't multiply anything by 3 to get it to 5. And I can't multiply something by 5 and get it to 3. So you have to multiply. The easiest thing is usually to multiply by the opposite number, but you can also think about their least common multiple. So they can both get to 15, right? 3 goes into 15 and 5 goes into 15. So you're going to try to get them both into a number that they can both go into. So with the first equation, I'm going to multiply all of this by 5. Because again, I want y to be eliminating, but I want y to also be the same number, and they have to be opposite signs. Right now it's +3 and -5, and that would give me -2. And that's no bueno because we need it to eliminate. So I'm going to multiply everything by +5. So 5 times -5x is -25x. 5 times +3y is +15y. 5 times -31 is -155. I know that's not super pretty, but that's what we got. Okay, now this one causes some plastic surgery on the first and the second, so I'm going to have to multiply this equation by 3 because I want that y to also be 15 in this one as well so I can eliminate them. 3 times -2 is -6x. 3 times -5y is -15y, and 3 times 0 is just 0. So my equations are stacked upon each other, which is good. And what do you notice? My 15s can cancel. My y's can cancel and eliminate. So that's why we multiplied by 3 and 5. We're trying to get y to be the same number so that we can eliminate them. And we chose the y to eliminate because they're opposite signs already. So then I'm going to put my little giant plus sign. -25x plus -6x is going to give us -31x. Positive 15y plus -15y is 0 equals -155 plus 0, which is just -155. And you're going to divide everything by negative 31 to get that x by itself. X equals positive 5. All right, so again, pick one of your equations. It doesn't matter which one. I'm going to pick the first one just because I like to. And you're going to substitute, right? You always use substitution for that second part. You're going to plug in x, or plug in 5 for the x value of the other equation. And anytime you plug in, you use parentheses. Okay, I have negative 25 plus 3y equals negative 31. Plus 25 on both sides. 3y equals negative 6. Divide both sides by 3. I get y equals negative 2. All right, so our solution here is 5 comma negative 2. All right, moving on. We have 2 problems left. And again, every problem's been a little bit different. That's why there's so many, because I'm trying to show you all of the cases that you're going to run into. And hopefully you're still watching this video if you're taking notes. I really hope so. So, number 7, we have negative 6x plus 5y equals negative 22. And then we have 15y minus 5x equals 25. Now, what do you notice about this problem? You also make sure it's in standard form. And right now, the second equation is not in standard form. So I need to write it in standard form. So let me go ahead and copy down the first equation again. So negative 6x plus 5y equals negative 22. And then let's rewrite that second equation below in standard form. So it's going to be negative 5x plus 15y equals 25. You want to make sure those are, in standard form. You want to make sure your variables are all stacked on top of each other so that you can actually combine them. Okay, you want to check for something that you can eliminate, so you want to look for opposite signs or the same number. However, in this case, we do not have the opportunity to do that. You always want to do the easiest possible, so if we can do plastic surgery on just one, that's the goal. If we have to do it on 2 of them, we'll survive, but it's not as super nice, right? So with negative 6 and negative 5, that's not as easy to get to the same number. But I think I could get the 5 and 15 to eliminate because I can get 5 to become 15 by multiplying everything by a 3. But I also need an opposite sign, so I'm going to multiply everything by negative 3. So I'm going to multiply all of this by negative 3. Negative 3 times negative 6x is going to be positive 18x. Negative 3 times positive 5y is going to be negative 15y. Negative 3 times negative 22 is positive 66. Okay, so now you can check and be like, yes, I can eliminate something. So let me draw my addition. Negative 5x plus 18x is going to give me 13x. 15y minus 15y eliminates and becomes nothing. And then 25 plus 66 is going to give me 91. And then you want to divide both sides by 13. And that's going to be 7. Okay, are you done? Nope, because you have to have a solution point. So you pick one of your equations. Let's pick the second one just to be different for once. So I'm going to plug this value in for my x value. So then we have 15y minus 35 equals 25. I'm going to add 35 to both sides. And you get y by itself, so you divide both sides by 15. Y equals 4. Okay, now the only step that was really hard was just remembering what to do to manipulate. So again, you want those numbers to be exactly the same. So you multiply by the least common, you multiply by a number to get it to the least common multiple, which is 15, right? You want that 5 and that 15 to be the same number. You could do the same thing with the 5 and the 6 by multiplying one by 6 and the other one by 5 so that you can get them both to 30. But I didn't want to do that because I only wanted to multiply one equation. So my solution here is 7, 4. There's lots of ways to do elimination. There's lots of hard ways to do it, and there's lots of easy ways. So I'm just showing you all the easy ways. Okay, And then number 8, some writing is off, but this is 3x plus 2y equals 12. And then 3x plus 2y equals 6. So here we got in some luck because our numbers are actually the same, just our signs are not the same. So you can either choose to eliminate the x's or you can eliminate the y's. I'm going to go ahead and choose to multiply the second equation by -1 because I'm going to eliminate the x's. So I have positive 3x in the first equation, so I want negative 3x, so I'm going to multiply everything by -1. -1 times 3x is negative 3x, -1 times 2y is negative 2y, and -1 times 6 equals negative 6. And then I'm going to copy that first equation back down so that I have them stacked and I can add a little bit better. And you should still be doing an addition sign no matter what. Negative 3x plus 3x cancels. Negative 2y plus 2y also cancels. So on that left side, I actually just have 0 because everything canceled out and it became 0. And then I have equals negative 6 plus 12, which gives me positive 6. Oh, you know what? This should be a negative because, oh no, I shouldn't. Am I going crazy? No, I'm not going crazy. Okay, sorry. So 0 equals 6. Does 0 equal 6? No. This doesn't make any sense, which it doesn't, right? Because 0 does not equal 6. So this means that this is going to be no solution. What does that mean about my graphs or my lines? If I were to graph these on a graph, if I were to put these lines onto a graph, they would be parallel to each other and they would not intersect, which means they're parallel and they have no solution. All right, so elimination can be something that's tricky, so if you have any questions, please feel free to reach out and ask for help.